In today's lesson, we're going to learn how to do some more stoichiometry problems, but this time we're going to get into solutions. So all the concepts you learned about stoichiometry are still the same. Mole ratios, limiting reactant, excess reactant, percent yield, any of those types of things that you learned last unit will work the same way here. But the only difference here is you might be dealing with some concentrations and volumes with masses rather than just masses like you would have seen in Unit 3. So you'll want your calculator, you'll want your periodic table, you'll want your list of ions, you'll want your solubility table, all of those things that deal with aqueous solutions and their reactions, you'll want to have those handy. So today's lesson is really just practicing 3 different types of stoichiometry problems together so you can see a few variations, and then making sure you try out a variety of problems with your homework. So there's 3 similar types of questions you can encounter in solution stoichiometry, and the first one we're going to see is dealing with calculating the concentration of ions. So we're going to start off with a question. There's 2 parts with it, and we're going to start with part A. It wants us to calculate the molar concentration of chloride ions, and very specifically just this type of ions, when 24.3 grams of magnesium chloride is dissolved in 100 milliliters of water. So let's start with part A, and then we'll come back and deal with part B. So first thing we want to consider is what's happening to the magnesium chloride when it's dissolved in water. So magnesium chloride starts off as a solid and it's an ionic compound. So when this ionic compound breaks apart um, into ions in solution, they're going to be aqueous. So we get magnesium ions, and always make sure that you put your charge with it. 1 magnesium. And we've got chloride ions, but there's 2 of them. So 2 chloride ions. This question is not a reaction, it's just creating a solution. We're dissolving a solid in water. So let's start writing down some information for what we're given. We have a mass, which is 24.3 grams. And our volume here is 100 milliliters. And we'll just assume, to make it a little bit easier here, that this is 3 significant digits. Right away, we're going to put that into liters, because we know if we're trying to find molar concentration, we're going to need liters. But remember, we're trying to find the molar concentration of chloride ions, which is over here. So we have to take information about the magnesium chloride and convert it into just chloride ions using this ionic equation that's here. So if we want to find molar concentration, we know we need moles and we know we need liters. We have our liters here, but this is definitely not moles. This is mass of magnesium chloride. So the first thing we want to do is find the number of moles of magnesium chloride. This is something you could do already on your own. So if you want to pause the video and just test yourself and see how much you remember from last unit on changing mass to moles, you can definitely try that now. If you need a refresher, just keep going. So our moles of magnesium chloride, what we do again, we take our mass, which is 24.3 grams, and we're going to multiply it by our ratio using our molar mass. Grams in the numerator, which means we want grams in the denominator. So for molar mass, our 1 mole goes on top and our mass goes on the bottom. Or another way of looking at it is you're taking your mass and dividing by the molar mass. So when we plug that into our calculator, we should get about 0.255 moles. But remember, this is moles of magnesium chloride. And in our question, we specifically want information with chloride ions. So this is where some of your stoichiometry comes in with a mole ratio. When we look at our balanced equation at the top, for every 1 magnesium chloride, there are 2 moles of chloride ions being produced. So we can do this calculation very easily. If we wanted to figure out how many moles of chloride ions there are, we can just use our mole ratio. And it sets itself up exactly the same way as we did last unit. So 0.255 moles of magnesium chloride, and we're going to multiply it by the mole ratio. My unknown goes on the top, 2 moles of chloride ions. And then on the bottom is going to go my 1 mole of magnesium chloride. So it's a 2-to-1 ratio, or what we really need to do here is just double our amount. So 0.255 times 2, and when we check that, we get 0.510 moles of chloride ions. Now we're in moles of chloride ions. If we want to find molar concentration, we have our moles and we have our volume. So the last part to this question is just solving for the concentration. What's our concentration of chloride ions? So this is our C is equal to N over V formula. So 0.510 moles, and we're going to divide that by zero point 0.1 liters. And remember, we're going to keep 3 significant digits here, we said. And so we should end up with 5.10 moles per liter. So that's the answer to part A. How many moles of chloride ions do we have? 5.1 moles per liter. Now, if we go back and take a look at part B, something different is happening here. So it says, find the molar concentration of chloride ions if 18.4 grams of lithium chloride that have been dissolved in 120 milliliters of water is added to the solution in part A. So that means to this solution here. So when we take a look at this question, it means we have our solution of magnesium chloride made up, and we are adding some lithium chloride to it. Lithium chloride has a volume and a mass. Do you see what ion is common between the two? It's the chloride ion. Magnesium and lithium are different ions, but the chloride are the same. So, if we're trying to solve part B, we need to figure out what's going on in part A in terms of chloride ions, which we already have done. We need to figure out what's going on in terms of chloride ions with part B with the lithium chloride, and then we need to combine them together. So let's try and break this down. So for part B, if we want to find the chloride ion concentration, we know we need moles over volume, but this time we have 2 solutions added together. So one way of looking at it is we take the moles of solution 1 from part A, and we find the moles of chloride ions from solution in part B, the lithium chloride, and add them together. And then our volume is going to change because each solution has a different volume. We take volume from solution 1 and we add it to the volume of solution 2. We already have moles of chloride ions and volume from part A, but what we need to find out is moles from the lithium chloride. We do have volume too because that was given to us in the question. So before we jump in and do this combined moles and combined volume, we need to find out exactly how many moles of lithium chloride we have. So we can start this part of the problem the same way that we did with part A. Lithium chloride is a solid. It will break apart into two ions, lithium ions and chloride ions. It's a 1-to-1 ratio here. And we have a mass, it said 18.4 grams. And we want to find the moles of chloride ions here. We're not going to jump in right to the concentration because we just want moles to be able to do that final calculation. So if you want, you can pause the video now and see if you can find out the chloride ion concentration here. And then we'll look at how to combine part A and B together. So if you've given this a try, let's take a look at the answer together. So if we want to find out first, we need moles of lithium chloride. We take our mass and we divide it by the molar mass. We'll use our ratio here, 1 mole over 42.39 grams. And that's going to give us about 4.434 moles of lithium chloride. But we need moles of chloride ions. So we take our moles of lithium chloride and multiply it by the mole ratio. But this is a nice mole ratio because it's 1-to-1. 1 mole of lithium chloride and 1 mole of chloride ions. So essentially we have the same number of moles, but we've done the proper accounting work with our units. So this is the moles of chloride ions. So now what we're going to do is go back to that formula we just saw, our combined formula here, and take our information from part A and part B and put it together to solve the question. So if I want to find my chloride ion concentration, I'm going to take my moles of chloride ions from part A. So let's go back up just so we can remember where that is. So this was part A. This number here represents how many moles of chloride ions we have, 0.150. So that's going to go in our formula. And we'll also need to put in our volume from part A, which is 0.1 liters. So we've got on the top 0.510 moles. And on the bottom, we've got 0.100 liters. The other half comes from part B. So part B, we just found how many moles of chloride ions there are. And then on the bottom, we put our volume, which was given to us in the question, 120 milliliters or 0.12 liters. And then we do the math. So add your numerator, add your denominator, then divide them and see what you get. When we do that, when we come back and take a look, if we're rounding to 3 significant digits like we said we would do for this question, you should get about 4.29 moles per liter. So again, this example goes through where you can see stoichiometry come into play when you're dealing with the concentration of ions in solution on its own, or what happens if you combine two solutions or combine masses, what's going to happen. So there's one good worksheet that's posted in your homework that has a variety of all sorts of ion concentration problems that you'll be able to try to see if you understood this concept and to try out some new problems. Next, we're going to continue with some more stoichiometry problems, but they're going to get into some reactions. So let's take a look at those. So these types of questions will often ask you to find the mass of a product. And when you're dealing with solutions, if it's the mass of a product, that means you're dealing with a precipitate. So these questions will ask you to figure out the mass of a precipitated compound. Since these are reactions, you will need balanced chemical equations. So this is going to test some of that knowledge. So let's read through this question. If 25 milliliters of a 6 mole per liter hydrochloric acid solution reacts with excess zinc, how many grams of zinc chloride are produced? So, with this question, the first thing that we need to do is write down a balanced chemical equation. So I'd like you to try and pause the video and see if you can write down a balanced chemical equation. And I want to see if you can include the states with it. So try that out. When you're ready to take a look, we'll look at the answer and move on with the question. So let's start taking a look at the balanced equation. All right, so we've got hydrochloric acid, zinc, zinc chloride, and we've got hydrogen gas. This is the other product here. This is a single displacement reaction. This is a gas. Make sure you balance by putting a 2 in front of the HCl. If you still need some help with balancing, definitely reach out and I'll be able to help you out with that. Now let's organize our information. So we have a volume and a concentration of hydrochloric acid. All right. Then we've got a piece of information here, excess zinc. Do you remember limiting and excess reactants? They come back here. But the nice thing about this question is they're telling you you have excess zinc. There's extra of it, so they're telling you this is your excess reactant. So the hydrochloric acid automatically becomes your limiting reactant, and that's what you're going to use to help you solve the problem. And here we want to know how much zinc chloride is produced. If we're able to collect it and take the mass of it, what would it be? So when we look at a question like this, you'll probably notice right away there are some similarities to unit number 3. We have information about a reactant. We're trying to find out information about a product. Even though the information starts out a little bit different with volume and concentration, the steps are going to be very similar to the stoichiometry problems you saw before. You have to go back to your mole roadmap, except this time it's going to start off with volume and concentration instead of a mass. So when we go from one compound to another, we know we need a mole ratio, and to use the mole ratio, we obviously need moles. So first step here, we would need to find out the moles of hydrochloric acid. Can we do that? Definitely. We've got C is equal to N over V, so we can rearrange that formula and we can find our moles of hydrochloric acid. Then we know how to go from hydrochloric acid to zinc chloride with our mole ratio. We can find out moles of zinc chloride that are here. This is step 2. This is exactly why you want to have a balanced equation here. It's a reaction. You want to make sure you have your right ratios by balancing with the coefficients because you'll need it in this step. Once you have your moles of zinc chloride, because the question wants us to know, well, what would that mass be that's dissolved in that solution? We need to find the mass. How do we do that? We use our ratio with molar mass. So these are the 3 steps. You've definitely done all of these steps individually. Finding moles using the concentration formula, doing a mole ratio, converting back to mass using molar mass. So see if you can do these 3 steps now that they're mapped out for you. So give the video a pause, try out those 3 steps. When you're ready, we'll take a look at the answers for those 3 steps together. So hopefully you've given this a shot. So let's start taking a look at the answers. Here they are way down here. So let's look at the first 2 steps together first. We want to find out the amount of moles of HCl. So we take our concentration and multiply it by our volume. The volume went from milliliters to liters. Make sure you always change that. And by putting in your units here, you can see, okay, liters and liters are going to cancel out. So I know I did that conversion properly. Yes, it's tedious to put some of the units in sometimes, but it catches silly mistakes if you forget to do that conversion. So you should get 0.15 moles. Then you need to do your mole ratio. When you look at your balanced equation, there's 2 moles of HCl for every 1 mole of zinc chloride. So it's a 2 to 1 ratio. So when we put it in, we take our moles of HCl on the top in the numerator, and they need to cancel with moles of HCl in the denominator. And then we're left with moles of zinc chloride, where essentially we're dividing by 2. So 0.15 divided by 2 gives us 0.075. Once you've done step 2, then you need to change your moles into mass using the molar mass of zinc chloride. And that again, you need your periodic table for. So looking at the last part, you've probably done this so many times now. Take our moles, multiply it by the molar mass, and we're going to get about 10.223 grams. And then for this question, we want to round to 3 significant digits in our answer. So we're going to round to 10.2 grams. So hopefully you can see by breaking this down into steps and mapping it out like we've done before. This is very similar to stoichiometry problem from Unit 3, but the difference is now volume is involved. So let's try out one more problem together and see how you do with a question where an extra step is added in. So here's our last problem for the lesson. You have 25 milliliters of a 0.085 mole per liter aqueous sodium sulfide solution. It's added to 56.5 milliliters of 0.1 mole per liter mercury 2 nitrate, and we want to figure out what the mass of the mercury 2 sulfide is that precipitates. Again, this question does not give you a balanced chemical reaction. So again, what I would recommend doing, pause the video, practice writing out that balanced chemical equation with your states. And when you're ready to check unpause, and we'll continue on with the question together. So hopefully you gave this one a try. So here's your balanced chemical equation. Sodium sulfide is aqueous. That's even given to you in the question. Sometimes there's some clues there. We've got a solution of mercury 2 nitrate, so we know it's aqueous as well. The precipitate was already told to us, mercury 2 sulfide. We just needed to check out, well, what's our other product and what's its solubility? Sodium nitrate is aqueous. Nitrates tend to be pretty much all aqueous, so it's safe to say that would be aqueous and then balance. Next, what we're going to do is organize the information that we have. So we have a volume of the sodium sulfide, 25 milliliters. And the concentration is 0.85 moles per liter. Next, we're going to do the same thing for mercury 2 nitrate. Volume of 56.5 milliliters. And concentration is 0.1 moles per liter. And we want to find out what the mass of our mercury sulfide is. So this might sound similar to the previous question, but there's one thing right away that should jump out at you that's different. What's different here is they haven't told us something is in excess. They've given us amounts for both of our reactants. We have an amount for sodium sulfide, and you have an amount for mercury 2 nitrate. So this is not a problem, but it adds an extra step to it. So guess what we have to do? We have to figure out which one of these two is our limiting reactant. And we do that the same way as we did before. We need to find the moles and then divide by the coefficients. But the difference here is we're going to use volume and concentration to find moles for both. So we need to find out how many moles of sodium sulfide we have by taking our concentration times our volume. And we need to do the same thing for mercury 2 nitrate. And then find the limiting reactant between the two. So if you think you can do this, pause your video, see if you can find out the moles of each, and then once you have moles, figure out the limiting reactant. So if I'm going to try and find out the limiting reactant, I need to do my calculation. So 0.085 moles per liter. Make sure you change your volumes to liters. And I should get 2.125 times 10 to the negative 3 moles. Then I'm going to do the same thing for my mercury 2 nitrate. 0.10 moles per liter. And I'm going to multiply it by the volume. And I should end up with 5.65 times 10 to the negative 3 moles. Okay. Now remember when we're finding limiting reactant, we said we're going to divide by the coefficient. So there's a coefficient of 1 in front of sodium sulfide. So this number would be divided by 1. And there's a 1 in front of the mercury 2 nitrate. So we divide this by 1. So luckily for us, it's the same ratio between the two divided by 1. So this isn't going to change our numbers, but we need to check this step because in other examples there might be a coefficient that's not 1, so we need to check. And then which one is smaller out of the two? This one's smaller. So since this one is smaller, this is our limiting reactant. So going forward, if I'm going to try and find the mass of my product, I need to use my limiting reactant, which is sodium sulfide. And then we follow the same 3 steps that we did with the previous question to try and find the mass of my product. I need to use my limiting reactant to find my mass of my product. I already have step 1 done because I have my moles. So then I need to do my mole ratio step and my mass step. So if you think you can try this, see if you can find out now the mass of the product. Pause the video, and then when you're ready to check, I'll continue walking through the rest of the problem. So let's walk through the rest together. We have moles of our limiting reactant. We need to find moles of our product. So moles of magnesium, oh sorry, not magnesium, mercury sulfide, mercury 2 sulfide. We take our moles of our limiting reactant, 2.125 times 10 to the negative 3 moles of sodium sulfide. And I'm going to multiply that by my mole ratio. When I go back up to my equation here, it's a 1-to-1 ratio between my reactant and product, which is nice. So I've got 1 mole of mercury 2 sulfide for 1 mole of sodium sulfide. So my number doesn't change here. And then Again, the same final step. Once I have the moles of my product, I need to change it into mass of product. So I'm going to take my moles from the previous calculation, and I'm going to multiply it by my molar mass of mercury 2 sulfide, which should be about 232.66 grams per mole. And I should get about 0.4944 grams. And then when I take a look at the question, there's a couple of different measurements here with different significant digits, but the smallest number of significant digits is 2. So for my final answer, I'm going to round it to about 0.49 grams. So you'll have, again, a good variety of questions to practice. They're all a little bit different, but once you figure out what you're working with, you end up doing a lot of the same steps. There can even be a few questions where percent yield is thrown in to make it even extra challenging. So try as many problems as you can on those sheets. Make sure you ask questions if you need help. And then we're going to move on after this to problems involving acids and bases, and stoichiometry will come back again there as well.